Hi, this is Will Martin from peakoilproof.com. Today I just wanted to do a quick video talking about substitution and specifically substituting from fossil fuel gasoline to renewable energy electric cars. So this is the just framework, the conceptual framework of how substitution occurs. If you're in an Econ 101 class, you might see a curve like this. In the green line is just showing that fossil fuel energy goes up over time in price, and the blue line sort of shows that renewable energy in general stays the same. You know, as it becomes more and more expensive to get fossil fuels out of the ground, the price goes up. But there's always the same amount of sunshine, right? So the cost of solar stays about the same, or actually goes down over time as it becomes cheaper to manufacture solar panels. So once those two lines cross, it's called the parity point. When you're talking about the electrical grid, it's called the grid parity point. Once that parity point is reached, people essentially substitute over from one source of energy that's getting more expensive to another source of energy that's staying the same or getting less expensive. And so the market price of energy shifts as people choose to, for example, put rooftop solar on their house instead of continue to buy energy that's produced with fossil fuels. So that's the general idea of substitution. What's interesting is that the U.S. Department of Energy has this metric they call the eGallon, and essentially what they're trying to do is show people what it would cost to drive an electric car on a per gallon basis instead of on a per mile basis. People have a hard time sort of understanding, the cost of driving their car. Like a total cost of ownership is about 60 cents a mile for the average car in the U.S., and that's including the price of gasoline. People don't really think about driving on a per mile basis. They think about it on a per gallon basis because the gallon cost is what they see up in big numbers on their neighborhood gas station. So energy.gov put up this metric. They basically take how much energy an electric car uses per mile, the cost of electricity for the average person on cents per kilowatt hour, and then convert it to the equivalent price per gallon of gasoline relative to the average fuel consumption of the average gasoline-powered car in the U.S. So it's a pretty interesting metric they use, and right now it shows that if you bought an electric car, it'd be considerably cheaper on a sort of per gallon basis or a per mile basis to drive the electric car, even when taking into consideration the fact that the gasoline price has come down dramatically over the last few months as the price of oil has come down. So this is a metric they use, and I'm gonna try to use this metric to circle back to that substitution curve and use real data to sort of show historically what the cost would be to put rooftop solar on your house and charge your electric car with that, as opposed to just buying gasoline. So the cost of residential solar has gone down dramatically over time, and these are some estimates of the LCOE. LCOE is the levelized cost of electricity, or levelized cost of energy, and it's a metric that takes into account the full life cycle cost of electricity generation, and it allows you to sort of do an apples to apples comparison between different types of electrical generation. And this takes into account not only the sort of variable cost, the per day cost of, for example, if you're generating electricity with coal, what's the price of coal per ton, right? But it also takes into account the capital cost of building a coal power plant, and then the time value of money of building a plant, and so you can take all that together, and it gives you sort of an apples-to-apples comparison. So the LCOE of residential solar, which is rooftop solar essentially on your house, has come down dramatically over time. And these are a few forecasts showing that it will likely continue to decrease in price over time, well into the future. Now, the gasoline price has come up dramatically over the last couple of decades. This is the blue line is the historic average U.S. gasoline price, and for the model's sake, the assumption I'm using is that the price of gasoline will continue to increase over the next few decades at the historic 5-year compounded annual growth rate of gasoline. So that's what this looks like. This is the assumption I'm using for the model to show you. And here's the results of the model. And this shows that the cost of driving an electric car that you charged using rooftop solar not only has come down dramatically, but actually in 2012 became cheaper than filling your car, a gasoline car, with gasoline and driving it that way. So this shows the actual substitution curve, which was the first slide I showed you. This is using actual real data. This is what it looks like in real life. And using those assumptions of what the price would be going forward, we see the discrepancy increasing over time as it becomes essentially cheaper and cheaper to drive an electric car that you charge using rooftop solar, and more expensive to drive a gasoline car. So this is my model. I'm gonna put this up on my website at peakoilproof.com, and for anyone that wants to play around with it and play around with the assumptions, it'll be available there. Thanks.